Hello guys, so now I'll be explaining the chapter 4 CQD. If I have time, I'll be doing the past papers. If not, I'll let you guys do it by yourselves. So let's start with section 4.1, the turning effect of a force. We need to define the moment of a force. The moment of the force, or the torque, means what? It is the quantitative measure of the turning effect. So remember, anytime they ask about the definition of a moment or the torque, it's the quantitative measure of the turning effect. Now 4.2. Using a spring balance calibrated in newtons, a Newton meter, apply force F at a handle of the door perpendicular to the plane of the door. Then apply a smaller force F prime also at the handle and perpendicular to the plane of the door. Which force has a larger turning effect? Definitely, if the force is greater than the turning effect is greater. Remember, the turning effect, the equation is force times perpendicular distance. So the distance has to be perpendicular and the force. So it's dependent on the force and the distance. So the farther away, like the greater the distance and the greater the force, the greater the force of rotation will be, or the moment will be. So that's for part A. Part B, using the Newton meter, apply a force F at the handle of a door perpendicular to the plane of the door. Then apply an equal force F prime also perpendicular to the plane of the door, but at a point closer to the hinge or axis rotation O. So like we said here, we made a bigger force than here. So the bigger the force, the bigger the rotation. Also, the larger the distance, the larger the rotation. So that's for question number 2. Now question number 3. What is the magnitude of the force of a moment around the pivot? Give each of the meanings, or give the meaning of each term. We know that the rule is the moment of a force is equal to force times distance. F is the force, D is the perpendicular distance, and then you will get the moment. So to put it in a sentence, we can say that the magnitude of a force is given by the magnitude or the moment, the moment of a force is given by the moment is equal to force times distance, where the force is the magnitude and the D is the perpendicular distance from the axis of rotation. Now we need to find the moment of each of the forces shown in the diagram. First about point A, then about point B. So the first thing we need to do is taking A as the axis of rotation, and then the second is to take B as the axis of rotation. Definitely, if it passes through the axis, then it is what? Its moment is equal to 0. So, okay, so if it's passing through the axis, then its moment is 0. For about A, the moment 1 about A is 0 because it passes through the axis A. The moment 2 about A is 0 since it also passes in the axis A. Moment 3 about A is the force, which is 30 newtons, multiplied by the perpendicular distance. So to find the perpendicular distance, we're going to elongate it, and here it is given, so it is 3 meters. So 30 times 3 meters, so it's 90 Newton per meter. Now the moment of force 4 about A is, so this is the force 4. It has a magnitude of 10 and a distance of 7 meters. So 10 times 7, it's going to be 70 Newton per meter. That was about A. Now about B, we're going to do force 1, or no, not force 1, magnitude 1 about B. It is force 1, which is 15 newtons, times the distance between, the perpendicular distance between force 1 and B, which if you do Pythagorean theorem, you will get 4 meters. So 15 times 4 is 60 Newton per meter. Then moment 2 about B is force 2 is 20 newtons multiplied by the perpendicular distance from the force to axis B, which is 5 meters. So it is 100 Newton per meter. Now F3 is passing through the axis B, so moment 3 about B is 0. And finally, moment 4 about B is going to be 10 times 2, which is 20 Newton per meter. Now, question number 5. Consider the following canvas ABCD. Determine the magnitude of the moment of force F around point B. We know the rule for magnitude is force times distance. The force of F, which is 4 newtons, multiplied by the perpendicular distance from F to D, which is 60 centimeters. If we change it to meters, it's 0.6 meters. So it's going to be 4 Newton times 0.6 meter. If we do it on the calculator, it is going to be 2.4 Newton per meter. So that is number 5 done. Number 6, which of the following, what is the direction of the torques produced by the forces acting on the spanner? So we have two types of forces. We have clockwise and we have counterclockwise. So by applying the right hand rule, you guys should know how to do this, okay? You put your right hand on the force, okay? If the force is pointing down, you put your fingers down, and the inside of your hand, which is your palm, has to be facing the axis. This is our axis in this case, okay? So let's say is one clockwise or counterclockwise? Remember, clockwise is negative and inside. Counterclockwise is positive and outside. So, when we're talking about negative inside, positive outside, we're talking about our thumb. So how are we going to do it? Let's do it for force 1. You put your fingers pointing downwards and your palm will be facing towards the left because that's where the axis is. And so you'll notice your thumb is pointing inwards. So if it's pointing inwards, then it's negative. If it's negative, then it has a clockwise direction. Same thing goes for force number 3 and force number 2. So negative has a clockwise. 4 passes through the axis, so it will not have a moment. So we say 0 moment. 5, if we're going to do it, our fingers will be pointing upward and our palm will be facing towards the left, towards the axis, and your thumb will be pointing outside. So since it's pointing outside, it's positive. That means it has a counterclockwise direction. Now, question number 7. In the following cases, the axis of rotation O is normal to the page. Determine the magnitude and direction of the moment vector of the force. Very simply, the first thing we're going to do is that we're going to do force times the perpendicular distance. So 3 newtons multiplied by 2 meters. We're going to get 6 Newton per meter. Now to check if it's positive or negative, we're going to use the right hand rule. We're going to put our right hand on the force and our palm will be facing upward because the axis of rotation O is upwards. So since it's facing upwards, our thumb will be pointing outwards. And since our thumb is outwards, it is positive. That means it is counterclockwise rotation. Now, for part B, it's going to be 2 Newton times 2 meter, which is 4 meter. If we're going to apply the right hand rule, you will get that your thumb will be pointing inside. So if it's inside, it is negative. So in fact, it's negative 4 Newton per meter. And since it is negative, it is what? Clockwise. So that was it for question number 7. Now question number 8. We need to know what the direction of the moment of F around O. So to do it, we're going to use the right hand rule. Doing the right hand rule, we're going to put our right hand. Our fingers will be pointing to the right in the direction of where the arrow is pointing, and our palm will be pointing downwards towards the axis. And so then our thumb will be pointing inside. So then it is clockwise and negative. Sometimes they will ask you into the plane of the picture. So into plane of picture means clockwise negative. Out of plane picture means out and counterclockwise positive. So that's question number 8. Question number 9. Determine the magnitude and direction of the resultant moment in each of the following cases. So to determine the magnitude and direction of the resultant forces, first of all, when we have more than one force at the same time, we're gonna add them. So we're gonna have a total moment. It will be equal to the moment of the first force plus the moment of the second force. So the moment of the first force is 3 newtons multiplied by the perpendicular distance, which is 2 meters. Now we check, is it positive or negative? We do the right hand rule and we get that it is positive. Now plus, again, we're gonna do the force times the perpendicular distance, which is 3 meters. Now we check, is it positive or negative? Using the right hand rule, we get it is positive. So the total moment is equal to plus 3 newton times 2 meter plus 2 times 3. So the total moment is equal to 12 newton per meter. And since it is positive, that means it's going in the counterclockwise direction. Now for the second one, we have the total moment is equal to moment 1 plus moment 2. Moment 1 is 2 newtons multiplied by the perpendicular distance, which is 2 meters. And by doing the right hand rule, we get that it is negative. Plus moment 2. Moment 2 is 1 newton multiplied by 1 meter. And then if we do the right hand rule, we will get that it is also negative. So minus 4 newton per meter plus minus 1 newton per meter, we will get minus 5 newton per meter, and the direction is clockwise. So that's question number 9 done. Section 4.6, the moment of a couple. So what are the characteristics of the forces that form a couple? They have to have equal magnitude. Okay, they should be parallel, not coinciding, non-coinciding, and they should be oppositely directed. So these are the characteristics that form a couple. Now here, this is a very nice question. In the figure below, the ratio of the radius of the outer circle, which is the bigger circle, the outer circle to that of the inner circle is 5 out of 2. So let's say this is the radius r of the smaller circle or the inner circle, and this is the radius capital R to that of what? To that of the bigger circle. So they said the outer or bigger circle over the smaller or inner. So capital R over small r is equal to 5 over 2. They told us we need to find the magnitude F for each of the two forces so that the net moment of the two couples is 0. So very simply, the moment of a couple is equal to the force times the distance between both forces. So if we're gonna do the moment of the 200 Newton, it will be moment is equal to 200 multiplied by the distance, which is small r plus small r. So it is 2 times small r. It is now equal to the moment of F. Moment of F is force multiplied by 2 times capital R. So we said they are equal to each other, صح? So 200 times 2 times R is equal to what is equal to F times 2 times R. So the 2 and the 2 will cancel. So now we have 200 times R is equal to F times capital R. Bring this down and bring this down. You will now have what? 200 over F is equal to R over R. And we know that capital R over small r is 5 over 2. So now 200 over F is equal to 5 over 2. So F times 5 is equal to 400. Divide both sides by 5. We will get that then F is equal to 80. So now we know that the force is 80 newtons. Now for point 7, okay, we have balancing parallel forces. Very simple. The only equation we're going to be using is all forces up is equal to all forces down. So consider a meter stick of negligible weight. Actually, not all forces. All moment up is equal to all moment down. So all moment equal all moment, and also all force up equal all force down. So keep these two in mind. Alright? Consider a meter stick of negligible weight. So let's draw it. We have a meter stick. It has no weight. We apply on both extremities of the meter a downward force of 10 newtons. So over here is 10. Okay. And over here we have as well 10. So 10 newtons, 10 newtons. And they also told us at point O, let's say point O is over here, they added a 3 kg mass. So if we're going to convert it to a force, it will be 3 times 10, which is 30 newtons. How did we change from kg to force? We just multiplied it by 10. So now they said, where should a single force F be applied in order to balance the stick? First of all, to find out what the single force F is, we're going to do all force up equal all force down. So all the force up is going to be one singular force, which is 10 plus 30 plus 10, which is 50 newtons. So 50 newton is equal to 10 newton plus 30 newton plus 10 newton again. Now, we know what? We know that it is balanced. Whenever they tell us balanced, that means the moment of counterclockwise, or the moment of clockwise, is equal to the moment of counterclockwise. So, the moment of first let's take the moment of clockwise. We know the moment of clockwise is, let's take for example a force T, which is 10 newtons. So 10 newtons, we're gonna find its moment. Okay, we're gonna multiply it by a distance x, a perpendicular distance x from a point, and it has to be equal to what? To the moment of the counterclockwise. So we're gonna do the same thing, and now it's gonna be what? 10, which is the force, multiplied by what? Multiplied by the total length of the stick, which is 1 meter minus x. So it becomes 10x is equal to 10 minus 10x. Move this to the other side, you are gonna get that 20x is equal to 10, so then x is equal to 0.5. So you should put the stick at a distance of 0.5 meters in order to balance it. So now we have, given the meter stick is of negligible mass shown below, find A, the single force that will balance the stick, okay, and B, the resultant of the two downward pulls, okay. First of all, the force that will balance them is what? All forces up is equal to all forces down. The only force up is gonna be equal to the forces down, which is 3 kg times 10 plus 2 kg times 10. So 30 plus 20, which is 50 newton. So the only force exerted upward should be 50 newton. Now, they didn't ask us about where the center of gravity would be, but I would like to apply it, okay? The center of gravity, or something like this. Whenever we have something like this, what do? We take any random one, for example 3 kg. We're going to find the center of gravity from the 3 kg weight. So we're going to do 3 kg times 10, because we need it to become a force, times the distance, which we need to find, which we will call x. So what we're doing is that the moment clockwise has to be equal to the moment of counterclockwise. Okay, it's equal to 2 times the 10 times what? Times the total length, which is 1 minus x. Okay, so far it's really understandable what we did. So we got 30x is equal to 20 minus 20x. You guys have to know how to solve this. Bring this to the other side, you get 50x is equal to 20. So x is equal to 20 over 50, which is 0.4. So you should put it at a distance of 0.4 meters from the 3 kg. If you want to know the distance from the center of gravity to the 2 kg, it will be 1 minus 0.4 meters, so it's 0.6 meters. Notice always that the center of gravity is closer towards the heavier object, okay? Now, section 4.9. The centers of gravity A, B, and C of 3 bodies constituting a system S form an equilateral triangle of side 8 centimeters. So we have an equilateral triangle. I'm not the best at drawing equilateral, so let's say this is equilateral. Each side has a side of 8 centimeters. Now they told us find the center of gravity knowing that the system S, knowing that the mass A is 0.3 kg, the mass B is 0.1 kg, and the mass C is 0.4 kg. Okay, so the very first thing we're gonna do is we are gonna find, first of all, the center of gravity. Let's call this A, B, C. Okay, let's say we have a lamina, for example. It's suspended from point C all the way until here, which we will call point D. Now we know that the rule of the center of gravity is the force, okay? The force 1 multiplied by the perpendicular distance 1, or like it was force 1 times x is equal to force 2 times the total distance, which is 8 minus x. In this case, look how we're gonna do it. We're gonna take the force as the weight. So now, the weight of A times the distance from this, so we're gonna say times dA, is equal to the weight of B times 8 minus dA, which is what is left, BD. So far understood? So now we have the values of weight A and weight B. We can do 0.3 times 10, so 30 times dA is equal to 10 times BD. Then bring this to the other side and bring this to the other side. You will get that 30 over 10, which is 3, is equal to BD over dA. So like that we found what? We found the center of gravity. So the center of gravity of A and B is equal to 3 centimeter. Or no, 3. Actually, we didn't prove this yet. Look what we proved. We proved that BD over dA is 3. So that means BD is equal to 3 times dA. Yeah? So using this, we can find what we can find the length over here. So very simply, we know that BD plus dA is equal to 8 centimeters. We know BD is 3dA, so 3dA plus dA is equal to 8 centimeters. So 4dA is equal to 8 centimeters. So then dA is equal to 2 centimeters. If this is 2 centimeters, then this is 8 minus 2, which is 6 centimeters. So then we can actually notice something else. The full side is what? 8 centimeters. صح? And then the measurement of dA is 2 centimeters. So if you do dA over the total, which is BA, you will get 2 over 8, which is 1 over 4. And since it is an equilateral triangle, then like that we would have found what? We would have found the center of gravity, which is that 1 over 4, in the case that dA is a fourth of BA. So in conclusion, I don't think this will be coming in the periodic, but it's something really nice to know. Question number 15. This is a good question. It's really tricky, so please pay attention. A pin is formed of a spherical tip of mass 5 grams. So let me zoom in. It's very beneficial if I zoom in. Okay, so mass 5 grams. So 5 grams, change it to kilograms, it is 0.05 kg. Actually, no, I did another calculation mistake. It is 0.005 kg. And a radius of 1 centimeter. So this over here is 1 centimeter. Okay. Now we also have a uniform rod of mass 10 grams. If you change it to kilograms, so 10 divided by 1,000, it is 0.01 kilogram, and a length of 8 centimeters. So the total length of this is what? 8 centimeters. They need us to find the center of gravity of the pin. So what we do is that we divide it into two objects. Already the sphere, they gave us the center of gravity, which is 1 centimeter away. It's in the middle. And here, since it's geometrical, okay, we can say that the center of gravity is also in the middle, so 4 centimeters. So if we're gonna combine the center of gravity of the rod and the sphere, it's gonna be 1 centimeter plus 4 centimeters gives us 5 centimeters. So we are looking for what? For the center of gravity of the pen. We have the center of gravity of the sphere, which is over here. We will call it point C, okay? Then we have the center of gravity of the rod, which we will call point D. Now, somewhere in between these two is a center of gravity, and we need to find it. So I'm gonna give you guys a rule, okay? You know that the moment of the clockwise is equal to the moment of the counterclockwise. The moment of the clockwise is force times distance is equal to force times distance. So force 1 times distance 1 is equal to force 2 times distance 2. Now the force in this case is the mass, so we're going to be using mass 1 times g times distance 1 is equal to mass 2 times g times distance 2. So we're going to cancel the g and the g. So now we're left with what? Mass 1 times distance 1 is equal to mass 2 times distance 2. So if we move this to the other side and this over here, we will get that distance 1 over distance 2 is equal to mass 2 over mass 1. Let's say we are doing rod over sphere. Or my bad, the sphere should be the sphere over the rod, because the sphere is, what is the mass? 5 grams over the mass of the rod, which is 10 grams. So we are going to get 1 over 2. So now we have that the distance from the final center of gravity to the rod's center of gravity over the distance to the tip center is 1 over 2. So that means what? That means the distance 1 over distance 2 is equal to 1 over 2. So distance 2 is equal to distance 1 times 2. So if we are going to rewrite the equation, it's going to be mass 1 times distance 1 is equal to mass 2 times 2 times distance 1. Another thing is that we know distance 1 plus distance 2 is equal to what? 5 centimeters. Isn't that true? So we know that distance 2 is distance 1 times 2. So it becomes distance 1 plus 2 distance 1 is equal to 5 centimeters. So now 3 distance 1 is equal to 5 centimeters. So distance 1 is equal to 5 over 3, which is 1.67 centimeters. So now we have distance 1 is equal to 1.67 centimeters. So now the overall center of gravity is what? Is the distance from point B to what? To distance 1. So let's say distance 1 is over here, okay? So it is gonna be then the total distance of the from point B to D1, so 4 centimeters plus over here, which is, and we know that distance 1 is 1.67 centimeters. So now to find the total distance of the center of gravity of the pin, we're going to do 4 plus 1.67 centimeters, which is 5.67 centimeters. I know this one is really confusing, really tricky, so try to watch it as many times as you want. And if you don't get it, message me and or like send a comment and I will re-explain it, okay? So we still have a couple of pages left and then we're done. Okay, so now we were in 4.10. So we are given a uniformly thin flat object of irregular shape. What's the best way to find its center of gravity? First thing we're gonna do is we're gonna use a lamina. So we're gonna suspend, or we're gonna suspend the object from a fixed point, and we're gonna allow it until it is in equilibrium. Okay, then we're gonna be using the lamina. Okay, when the lamina will stop moving, we will draw a vertical line. We will do it from many points, and then it will connect all in one point, which is the center of gravity. So that's 4.10 done. Now 4.11. We have question number 17. A uniform meter ruler AB of weight 0.95 newtons is supported on a knife edge placed at 45 centimeters from A. The meter ruler balances horizontally when a mass of 48 grams is suspended at a distance x from A. We need to find the value of x. Now I'm gonna give you guys something. We saw balances. Whenever we see balances, that means the moment of clockwise is equal to the moment of counterclockwise. So first of all, let us see which forces are clockwise and which forces are counterclockwise. By doing the right hand rule, you will see that from A as the axis, okay, we have T and G. They are what? They are clockwise. So we will put the moment of T plus the moment of G is clockwise. It has to be equal to the moment of the counterclockwise. Also doing the right hand rule, we will see that the force N is counterclockwise, so it's equal to the moment of the counterclockwise N. First of all, we know how much is the weight of, how much is the force W. It's 0.95 newtons. Second of all, we should know how much the force of this is. It is 48 grams. So to change it into a force, we're gonna first change it into kilograms. So 48 divided by 1000, which is 0.048 times 10. So it is 0.48 newtons. Okay? Now N keeps it balanced. So that means all the force up are equal to all the force down. So very simply, to find N, we can do N is equal to T plus W. Why? Because all the forces up are equal to all of the forces down. So 0.48 plus 0.95 is 1.43. So the force of N is 1.43 newtons. Now, first of all, we know that the moment of T is 0.48 times the distance we need to find, which is x, plus the moment of G, which is 0.95 times the distance from the center of gravity, which is what? Which is 0.5 meters. Okay? It's equal to what? To the force of N, which is 1.43, multiplied, 0.5 from the axis A, not from the center of gravity. And then 1.43 times the distance from it to the center of gravity, which is 45 centimeters, which is 0.45 meter. So by solving, you get 0.48x is equal to, or before it's equal to, 0.45x plus 0.95 times 0.5. So it is 0.4475 is equal to 1.43 times 0.45. So it is 0.6435. Move this to the other side, you will get that 0.48x is equal to so then we will subtract, we will get that 0.48x is equal to 0.1685. Then we divide from both sides, we get that x is equal to 0.35 meters, which is 35 centimeters. Now question number 18. A boy uses a spanner of length 24 centimeters. Length, we change it to meters. So 0.024 meters. Calculate the moment of his pull if he pulls at a right angle to the end of the spanner with a force of 50 newtons. Okay, what I am gonna do over here is very important. Please pay attention. We know moment is equal to force times perpendicular distance. So to find the perpendicular distance is really easy. Actually, the normal equation is moment is equal to force times distance times sine the angle made with the x-axis. So in this case, moment is equal to the force, which is 50 newtons, multiplied by the distance, which is 0.024. Oh my goodness, my bad. This is 0.24 meter. I did a calculation mistake. So 0.24 meters times the sine of the x-axis. They said it is what? It is right angled. So sine 90. Do it on your calculator. 50 times 0.24 times the sine of 90. We are gonna get 12. Okay? What happens if we increase it from 90 degrees to 120 degrees? It becomes moment is equal to force times distance times sine angle. 50 times 0.24 times sine 120. If we do it on our calculator, we are gonna get 10.4. So it decreases. So basically 90 is the maximum you can increase to. So after 90, if you increase, then the moment will decrease. Question number 19. The adjacent figure shows a man of mass 90 kg walking on a uniform beam of 80 kg. Okay, so first of all, we have what? We have the mass of the man, which is 90 kg. He's walking on a uniform beam that has a mass of 80 kg. Okay, there is a tension of the rope that can hold a maximum of 1000 newtons. They're asking how far can the man move before the cable breaks? Very nice question. What we have to know is that the maximum load or the minimum for it to tilt or topple, we use this equation. Moment clockwise is equal to moment counterclockwise. And now we're going to be talking about the moment from A. So the moment that is clockwise from A is the moment of 80 kg. So I'm going to say moment of weight, or moment of, weight, plus the moment of the man, the moment of the weight of the man. It has to be equal to what? To the moment of the tension. So the moment of the weight is 80 kg times 10 newtons times what? Times the distance. Since it is 6 meters and it is uniform and we're talking about the weight of the cable, okay, then it will be at its geometrical center. So the distance is gonna be 3 meters. Again, we're talking about the weight of the rope, the cable, okay? When we're talking about it, and it's a uniform object, by the way, it means that the center of gravity is exactly at the geometrical center. So it will cut it into two equal pieces. Here's 3 meters and here is 3 meters. So the distance from 80 kg to the axis is 3 meters. Plus the moment of the man, which is 90 times 10 times the distance we need to find, we will call it Z, is equal to the moment of the tension, which is 1000, the force, multiplied by the distance. The distance is the total distance, which is 6. So we will get 2400 plus 900 times Z is equal to 6000. Move this to the other side. 6000 minus 2400 is 3600. So 900 times Z is equal to 3600. Divide both sides by 900. We get Z is equal to 4 meters. So the maximum that the man can, the maximum distance the man can walk without the cable breaking is 4 meters. Question number 20. So right now I'll choose some questions. We have 20, 21, 22, 23, and 24. Okay, so 24 is really tricky. I don't think it will come. I will definitely do 23. 22, I won't do it. And so I'll do 20 and 21, okay? Or actually, to be honest, I changed my mind. I'm not gonna do 20. I'll do 21, 23, and 24, okay? So, I'm gonna skip 20. Let's go directly to 21. A girl of mass 50 kg sits on the right-hand side of a seesaw at a distance of 3.4 meters from the pivot. Another girl of weight 450 newtons. That means how much kg? 45 kg. How did we know? We divided by 10. She sits on the left-hand side. At what distance must she sit for the seesaw to balance? That means moment counterclockwise is equal to moment clockwise. So you can do force times distance. So 50 times 10, that's a force, which is 500 newtons, multiplied by the distance, which is 3.4 meters, is equal to the force, which is 450 newtons, multiplied by the distance, which we will call z. This is z, not 7, okay? So 500 times 3.4 is 1,700. It's equal to 450 times z. So then 1,700 divided by 450, it is gonna be approximately 3.77, which is 3.8 meters. Now 22, we said skip. 23 is very easy. Which of the following will fall? From the M, just draw. If it passes through the base, then it's definitely what? It's stable. So definitely they're all stable except for C, since C, it doesn't pass through the base line. Now finally 24. A boy is moving up a ladder of weight 50 newtons. So we have a weight, a force, 50 newtons, placed next to the wall. The horizontal force exerted by the wall on the ladder has a magnitude of horizontal 250 newtons. The vertical force exerted by the ground on the ladder is denoted V. The ladder is in equilibrium as long as the horizontal distance of the boy from B is less than X. Use G equals 9.8 meters per second. So let's go down. What's the first thing that they asked us? They told us the mass of the boy is 40 kg. Calculate the magnitude of his weight. Very simply, weight is equal to m times g. 40 kg times 9.8. So his weight is going to be approximately, actually it is 392. Now calculate the moment of the weight on the ladder W about point B. So what we're going to do here is we're going to take the weight of the ladder, which is 50 newtons. We are going to multiply it by the distance from the weight, which is 1.5 meters. And so then we get the moment, which is 75 Newton per meter. Now calculate the moment of force H about point B. Very simply, we know that force H is 250 newtons, and if you read the given, you will see that the distance from H to B is 2.8 meters. So it's going to be what? It's going to be 250 newtons times 2.8 meters, so it's 700 Newton per meter. Okay? Part D. Deduce the maximum distance x from point B that the boy can move without disturbing the equilibrium. We have to do what? We have to do that. In equilibrium, the moment of clockwise is equal to the moment of the counterclockwise. What's the moment of the clockwise? First of all, we got the moment of the weight. The moment of the weight is the the moment of the weight is the clockwise. So the weight of the ladder, which was 700 Newton, is equal to the moment of the counterclockwise force. Actually, the weight is the counterclockwise force, okay? And H is what? The horizontal is the clockwise force. So, my mistake for saying it and mixing it up. The horizontal force, which is 700 newtons, is the clockwise force, and the counterclockwise force, which is the weight, is 75 newtons. Okay? But we are going to add what? We are going to add the weight of the boy times the distance, the maximum distance he can move. So bring 75 to the other side. 700 minus 75 becomes 625. So now 625 is equal to the weight of the boy times the maximum distance he can move. His weight is, we did use that it was 392, sorry. So 625 is equal to 392 times the maximum distance, x. So bring it here and divide it by 392. It will be approximately, x is then approximately 1.6 or 1.59. Okay, 1.6 or 1.59. Now E deduce the magnitude of the force V. The magnitude of the force V is that okay, 1 second. We can apply the rule that all forces up equal all forces down. So the weight of the boy, which is 329, plus the weight of the ladder, which is 50, should be equal to the weight of, to the force of V. So if we do 329 plus 50, we are gonna get 370. Oh, my bad. You see, guys, when you mix up 392 plus 50, so 392 plus 50, we are then gonna get 442 Newtons. So this is the magnitude of V. Okay, now what other force acts on the ladder to keep it in equilibrium? So since we have a force H pushing like this, we should have a force going like this. So this force, we will call it friction. Okay, so the force of friction is another force applied, and it's applied leftwards. So thank you guys for watching. I hope you understood, and have a wonderful night.